Hey guys, and welcome to another 4th's Advanced C++ tutorials. In the last episode, we finally got all of our pieces together to be able to get the functionality we need on a design level, on what we're designing. But we still have a lot of work to do to make the C++ Lua hybrid as useful as possible, and that's that we need to do some work to polish the products, and we need to do some work to make the development process easier, and to get a good working system together to actually make these applications this way. So moving on from how to bind things to do all this binding work, we're gonna look at some other things. And the first thing we're gonna look at, that's gonna lead us down a road for a while, for another episode after this, is the compilation of Lua scripts. Now, once we start getting into compiling Lua scripts, it's going to create for us a number of problems to solve, and those problems, some of them we're going to solve in the next video. But we also have a number of problems to consider just in general that we can't solve. For example, if you're going to distribute your program with compiled scripts only, you won't be sharing and contributing to the Lua community. For programmers who are new to Lua to have something to look at. If you come up with some really great stuff, sure, you've protected it and kept it hidden, but you've also slowed the growth of Lua. So it depends on whether or not you want to be a contributor in the community with this, with whatever you're making, or if it's purely just an end product and you don't expect that your code is all that reusable. There's also considerations of people who want to expand on it. Say if you're making a game and you want it to be moddable, making it so that the sources can be edited will make it very easy to mod. It's the easiest way I think there is to make a game moddable, is to write it in open source Lua scripts. There's other ups and downs, but that's basically it. But let's talk about some of the benefits of compiling your Lua scripts too. First of all, like most obviously, is that when you are loading in Lua scripts natively, you're just loading them in and compiling them while you're loading them in and then finally executing them. You have to deal with the time it takes to compile them. If we compile them beforehand, once, then every time we run the program, we can just skip straight to executing those files. Also, there are considerations like, because of that slow turnaround, if we're going to do something like streaming of commands. Say I connect to a server and the server is actually going to give me the Lua that I should execute. If I'm sending the entire script, I have to not only get the strings being buffered in from the server, but I also have to then compile them once I finally received them all, and then I can execute them. If I'm streaming in commands compiled beforehand, then I can take those compiled commands and execute them right away. Now, what we've got so far doesn't allow us to do very easily sending an execution of little fragments of scripts from server to client. But that is, from what we learn making this kind of compiler, this sort of normal type of compilation system, we could also make a system that works like that. So what we're going to do is look at my compiling tool. Now, the fair warning before we get into it, the compiling tool is very difficult to follow. I think it's for sure one of the farther advanced things I've ever discussed on the channel, and that's because we're now getting into messing with the internals of Lua, and this should be the only video where we really do a lot of that. But to compile Lua scripts, we have to mess with the internal parts of Lua, and rather than the well-documented interface we've been seeing up until now. I think that's all I've got to say to get us started. So let's take a look at this. Okay, first of all, you can see I've included a lot more than lua.hpp because we need to get in the interfaces for a lot of internal stuff now. We are implementing the compiling tool header, which is really just a function that we can call, and as you can see, I call it there. So if we want to start, we can skip to that part. We can see I'm registering some functions at the bottom, but let's not skip to that. I mean, we have, but that's not really the best place where the interesting stuff happens, because as you can imagine, This is just a binding here. We've got the registration functions, which are registering these binding functions here. I keep calling it, the whole thing is the binding. We got the registration functions, which are registering the Lua compatible functions, binding this whole compiler to Lua scripts. And you'll see why in a bit, why I bind my compilation system to Lua scripts. But for now, let's take a look at the compiling code itself. What does the compiler look like? We're going to use some pretty easy to use stuff here. We're talking about a list of strings called the list of files. Whenever we begin a new compilation unit, each compilation unit will produce one file called a Lua C file. Since Lua scripts are called Lua, once we compile them, we just tack a C on the end of the Lua, and we have Lua compiled files, or .luac. So we have begin, which every time, like I said, we call begin, we clear the list of file names, and we begin a new compilation unit. Then we can, once we've begun compiling, we add file names to the list. So we're just coming up with our list of names to compile. Once we have our names ready, we can call compile. And that's the way the system works. Okay, so I skipped over some of these things here which are being used in the compile function. So let's take a quick look at those. Set PT value, that has to do something with a proto, and we'll get a better explanation of that later. How this internal stuff works, I don't even know. I can only tell you how the set PT value behaves, and beyond that, you'll have to do some drudging around in the source code yourself. The two proto function or macro here basically is going to be our way of, again, the proto is something we'll see a lot more once we get into it, but this is another stack operation. You're used to seeing like things like Lua to user data, Lua to integer, Lua to number, Lua to string. This is Lua to proto, except it doesn't have to start with Lua because this isn't even a part of an interface. To proto is just a macro that takes something, looks at an object in the stack and says this is that thing called proto and converts it to that. This isn't something we can do normally in Lua, but for purposes like this we can. Since we're already messing with all this sorts of internal stuff. We're at the layer where we can mess with protos on the stack now. Okay, the writer function is pretty straightforward. This is just my way of saying later on I'm going to take this writer function and I'm going to use it to dump the compiled data into a file. And depending on how we implement this writer function, it could do many different things. For example, this writer function could be redefined as a system for dumping the data into a packet and then sending that, and that's how you would set up the server client thing, except that's one way you could do it. So this writer function is basically expecting the user data, the void pointer there, to be a file, as you can see here as I convert it to a file, and then I'm just writing byte for byte what comes in as data into the file, and that's that. So let's look at the compilation function now, the big bad compilation function. First, we create a new Lua state. Now recall, we already are executing inside one Lua state. We're making scripts to compile other scripts. And those scripts are going to call the compile function, which is going to create a new Lua state. This is, I'm sure some of you started thinking about all the crazy possibilities that could go on as soon as you realized that you could have multiple Lua states existing simultaneously. This is the first time we're actually going to have that. We have Lua state number 2 created right here, and we're going to call Lua L new state. For just this one case, I used L, probably because I copied this from, a lot of this work I copied from the compiler. If you'll recall in the first video, we had to get rid of two files, lua.c and luac.c. And luac.c was kind of a mini example on how you might go about compiling Lua byte into a file. And I copied a lot of my work from that, and I think they probably used an L in the actual compilation function there. So that might be why I'm using an L here instead of an S that you're used to. Next, what we're going to do is loop through this list of files, and we're going to call Lua L load file on each one. So in the past, in my main function, as you've seen, I've called Lua L load file, and then I've called Lua call, because I just want to load that file, that main.lua, and then I want to call the main.lua. But now I'm not talking about, hey, let's make I'm not making a function that's supposed to call a bunch of scripts. I'm making a function that's supposed to look at these scripts and then before it calls them, take that state and drop it into a file, and then later on another program might call that. But for now, all I want to do is look at those, compile them, and resave whatever I got from compiling, never call it. So I'm loading in all of the files one at a time. Now we saw before that the way Lua call works and the way load file works is Lua call is going to call the first thing on the stack. And the reason this system setup right here works is because Lua L load file is going to take that main.lua, turn it basically into something I can call, and then put it on the stack as item on the top. And if I call multiple times, I'm going to get a stack full of different things that I can call. Like we said, we're not going to call any of them, we're just making a stack of these callable things. What we actually want to do is take this stack of callable things and convert it into one giant callable thing, and then, once it's one callable thing, we're going to dump it into a file. So now that we've seen this basic setup, let's look at the actual dirty work, the compiler and the dumper. The compiler starts by figuring out how many things I've just added to the stack, which will be equal to the size of the files list. And it creates this thing called a proto. Now I told you we were going to get into talking about protos, and here we are, we're right at proto. A proto, which is short for prototype, but I think the name proto is cooler. A proto is basically the prototype to a function. When you're making a function, you base it on a prototype, and that's what makes a proto callable. The thing that you call when you call a function turns out to be a proto. A function is a little bit more dressed up than a proto, but a proto can be called as well. And that's what we're going to actually be dealing with here. We've got to make a new proto. So this is the first thing that comes from a library we haven't used before. This is from the Lua function library, and it creates a new proto and puts on the stack. So now we have all the protos from the first time, from going through this iteration. We have all those protos and one more proto for the finished version. Next, what we're going to do is set to PT value L top F. What that really means is we are going to okay, so I said this adds it to the stack, but really it's just created the object. We have to manually add it to the stack since this isn't a proper Lua new user data or Lua new table. This is Lua new proto. It doesn't manually add something to the stack or automatically add something to the stack. We have to do that manually afterwards. So that's what set PT value does. It sets the top value on the stack to this proto and then increments the pointer on the stack up 1, so the next time something gets set on the stack, it'll not erase our proto. So that's what this line is for, is just adding the proto we just created to the stack. Next, we're going to edit stuff inside the proto for a bit. We need to tell it what type of source this is, so that if there's an error and it needs to put up a good error message, it'll be able to say, oh, the source of this error is a compiled script. I don't have the source. So that's the name of this source, is compiled scripts. If you ask me what this is, I'll have to say I don't know, because it's the one thing I don't think I've figured out, and if I did figure it out, I've forgotten now. Then what we're gonna do is PC. I forget what PC stands for, but PC is going to be 2 times the number of files we may had plus 1. And that's the number of instructions that the new proto is going to have. We have all the protos that were created by loading files, then we made a blank proto and we're setting it up, and the number of instructions that the new proto is going to have is equal to the number of files we loaded plus 1 more. So that's how many instructions are in this proto. Next, what we see is I'm using the Lua M library, the Lua memory library, to create a new vector in the Lua, in the Lua memory system, and that new vector is going to be a vector of instructions, like I said, or I was calling them commands, but a vector of instructions, and we need PC number of instructions. Then we of course tell the proto, since we were storing a block of data, how big that block of data is. It's always important if you have a block of memory to know how big it is. We're going to take a second vector, a vector of protos now, and one proto can be based on other protos via closure. This is a vector of the protos. Well, I mean, right now it is a vector of protos equal to the number of files we have, and incidentally, obviously, it's going to become true that each element of that vector is one of the protos we loaded earlier. And then, of course, we've got a block of memory. What size is it? We set PC back to 0 because we're going to increment it down here in our for loop. And we begin the for loop. Now, in each stage in the for loop, what we want to do is, first we want to set one of the elements in the proto, because the reason we have to do this first is the next line depends on it. So we say, for example, 0, the first proto is going to be the negative n minus 1 element on the stack. And if you do the math, that works out, because we have one extra, plus we have n. We started with n, we added one more. If we put negative of how many there are, we'll get the first element on the stack. So I will be 0 and we'll get the first element. Then I will be 1 and we'll get the second element. I will be 2 and we'll get the third element, and so on. So we'll get each proto that we loaded from the files and pair it up with the protos that are inside this proto, basically. Then we add an instruction to this proto, and the first instruction we add will be a closure instruction. Now, I can't exactly figure out what this does. I just know it's based on whatever proto we just set. So if this is the first proto and we've just told the major proto that we're building that its first proto is the first one that we loaded, then the first closure instruction is related to that first proto. That's as much as I can say about that. But then it becomes pretty clear when the second instruction is op call, because then what we see is the second instruction is an instruction to call that closure right here. Now, I still don't know what this does exactly. I assume it probably is something like a stack manipulation, push the closure on there, call it, or something similar to that idea. So we've got all these instructions saying, hey, call each of those. We have made instructions saying to call them, but we haven't actually called them, if that makes sense. And then finally, we add an instruction to return, which is what we need to end a proto. Every proto has to end with a return. So then it hits the return, and we finished compiling and building our new proto. So we've got the big compiled thing now. Next, we need to take that compiled thing and dump it into a file. That's the last step we have. And that's what all of this code right here will do. So first we're going to open a file. Dest file is an argument to this function, so that's where dest file comes from. When I call this function, whatever destination I want becomes the destination, and we are of course writing bytes. And I open the file. Next, I have to lock Lua, and it would seem that this doesn't do anything if you look at the definition in my version anyway. But I can conceive times where there's some sort of multi-threading going on, and having these lock-unlocks is important in certain places like this. But this particular version of Lua isn't for multi-threading, and so locking and unlocking is actually nothing. And then finally there's the dump function. Now, I don't know what U stands for, but we're using the Lua U library now, and we are going to dump this proto into this file via this writer. And stripping is a boolean that decides whether or not to strip debugging data from the proto. So when we can create these protos, we can give them debugging information, and if we strip all the debugging information, then when we run, we won't get the advantage of like being able to see our call stack and things like that. We won't have all the debugging tools that Lua is built in with, but that will make our code faster. So this is sort of a release debug thing. True for release, false for debug. So once we've called that, it will have created copied all the data into the file. We can unlock it, and then finally we can close the file. And that is the end of the dumping process. So now we've loaded all the files, compiled them into a single callable item, and then taken that callable item and dumped it back into a file. And that is the compilation system. Now, as far as why would I bind this? What would be the point in making it small? Am I trying to do something tricky here? Actually, no. I just found that it was easier to set up my compilation via Lua binding, and we'll see more of how can be used even more cleverly next time when we start dealing with a small issue once we start compiling. But for now, I think we've done enough for one video. So that's compiling for Lua scripts. See you guys next time.